So let me go to, first of all, the study guide, because I believe I'm pretty true to the study guides. It's always interesting to see people's reflections on it, because some people are like, "Well, you didn't stick to the study guide," and I'm like, how did I not? But um, let's take a look at that first. And then while I'm looking for it on my many millions of tabs, any questions that
So
are
we
like,
we don't take the midterm in class, or are we taking it in class on our computer?
it is completely on the computer. So for my hybrid students, um, no one had emailed me that they wanted to do a proctored final, because so in my hybrid class, if you take it in class, there's no second chance, right?
Yes.
If you take it online, you have two chances. And
Yeah.
so nobody
So
in the hybrid class wanted it in person.
yeah, so then yeah, we don't have to go to camp. We don't have to go to your class to take it on our computer. We can take it at home.
Correct. Yes. But our
Okay.
last day of class will be the presentations on,
On Thursday?
yes.
Okay, thank you.
You're welcome. Okay, so here is the study guide, just to go over it. Again, you have two separate cheat sheets that you can use, one for each part, and I strongly recommend it, right? I broke it up into two parts for your sanity. You do not want to be doing this exam all in one sitting. And so you have one page. I would say the first one definitely have APA components on it. That is a big chunk of the exam. You had all this term to practice your APA, and you will be tested on it, right? So the different parts, title page, abstract, introduction, method, those are components that you have. What's the purpose of each article section? Make sure you know the proper formatting for the title page, for the abstract, for the beginning of the body and the reference pages. So also, how are things phrased in APA 7 format? So the idea is it is formal. So there shouldn't be slang or contractions, things like that. It should be straightforward, and it should not have a ton of jargon, right? It should be something that people can read. Yes, it is formal. Yes, it is kind of expert and considered scholarly, but it shouldn't be so heavy in jargon that you need a dictionary every sentence, right? And then so there's three levels, right? The organization, and that helps with predictability so that people know where to find the information. Then you have the style, which is the style of writing, which I said is formal, neutral, should not be biased language. And then level three is the mechanics of it. So this is the part everybody loves, right? Like, what's italicized? What is capitalized? What is boldface? Where is there a space? All of that is important in APA 7 formatting. So there are many different formats to know in terms of reference page entries. What should you know? Book, scholarly periodical, electronic source. If there's one, two, or three authors or more. If there's no author, if there is no date. You should be able to tell, based on a reference page entry, whether or not it's a book or a scholarly periodical or an electronic source. And it all has to do with what is italicized, what is not, how do the dates look. So what's consistent? First element of a reference page entry should always be the author. If there is no author, then you will either have the organization that published it, for example, the National Institute of Health, or you would have the title. If you choose, the organization, you don't list it twice. If you choose the title, you don't list it twice. Okay. Secondly, second element should always be the publication year. The way the publication year looks will tell you whether it's a scholarly periodical or an electronic source. Electronic sources will have the day, month, and year. Scholarly periodicals only have the year. If there is no date, you'll still have a parentheses and N period, D period. And that indicates to the readers that you know the date's supposed to be there, but there was no date indicated. Right off the bat, it would not be a scholarly periodical if there's no date. Every scholarly periodical will have a date. Every book will have a date. Any questions about that part? Okay, 1, 2, 3 or more authors. One author, that's straightforward. Remember, it's only the last name and then the first initial, possibly the initial of the second name as well. If there are two authors, first of all, do not reorganize them alphabetically. Authors are listed in terms of contribution. Okay, so first author is the person who wrote the most. If you reorganize it alphabetically, you're actually discrediting the person who did the most work. Also, if there are two or more authors, there should be an and symbol in front of the last name of the last author. If there's no and symbol, that's an error. I will be strict in grading errors in this, okay, because you should have practiced it throughout. Also, in the reference page entries, I should not see at all. Every single name of every author, up to 20 authors, needs to be listed. If there are more than 20 authors, then you see ... and then the last author. You'd list all 20, and then anyone after the 20th, you would put ... and then the very last author. And yes, there are some papers that have that many authors, but unlikely that you would have any or see any of that. In a in-text citation, if there are 3 or more authors, then you would list only the last name of the first author, et al., period, comma, space, publication year. Questions about that part? I'm just kind of telling you off the bat what I'm thinking, what I'm remembering from the study guide.
Can you clarify a little bit more around like the nature of these types of questions? For example, will we be interpreting the meaning of a reference, or is it going to be like, here's a book, give it to me in APA format?
So because of the way the exams are formatted, I cannot ask you to give it to me in APA format because you can't do the proper indentation.
Okay.
But I could give you a reference page entry and say, what's wrong with this?
Okay.
And you would be like, this is missing. This is not italicized. This should. So that's where you would give me your feedback. That's a good question. Yes, you cannot actually type it in APA 7 format because of the way Canvas is. But I would give you, in the short answer, there would be a number of different options of, okay, I'll give you a flash of a reference page entry and you tell me what's wrong with it. So what I would probably do is, I'm trying to remember, I think I give you like all the information. This person is using this source with everything and, you know, everything possibly you could need. Is this the correct citation for the source? And you should be able to discern it from the information I give you. You should not have to guess anything. It should be all there. So here are some common errors. Again, I can give you a snapshot. So remember, on my online exams, it's a test bank. So I have many different versions of similar tests. So it could be just a little snippet of an APA 7, supposedly an APA 7 format paper with mistakes in it. What are the mistakes in it? It could be there are no mistakes in it, but these are common errors. So if somebody listed a number of 11 and wrote out the word ELEVEN, that's an APA 7 error, because according to APA 7, any numeral 10 and above, it should be a number, the Arabic number, not spelled out.
So under 10, it'll be spelled out?
Hyphenation is a big one. So 10 would not be spelled out under 10. So 9 would be spelled out 8, 7, 6, 5, 4, 3, 2. Yeah. Et al. Should be used. Actually, it's not even, so APA 6 was you would write out everything, but in APA 7, et al. Is used for 3 or more authors consistently. Since is not synonymous with because. Many people use that. Since should only be used if there's a reference to time. You know, ever since I was 6 years old, this is how I felt. That's a proper use of since. When people say, since it is raining, I wore boots. That's an incorrect use of the word since, because you're trying to say it because. Comma, APA 7 believes in the Oxford comma, so 3 or more elements, there should be a comma there. Abbreviations. You should spell out the whole thing. Even something as common as PTSD, the word should be spelled out before you use the term PTSD. Spacing, if there's, you know, many of you are going to see that, like, it should be consistent double spacing. You shouldn't have extra blank lines in between things. And then, of course, this is a really big one, the use of and, the symbol in references. If it's a direct citation, meaning that you are calling out the authors in your sentence, then you would use the word and. If it is a parenthetical citation, in other words, you're only citing the material and not, you know, quoting the authors, then you would use the and symbol in the citation. Questions about APA?
I have a question.
Mm-hmm.
For the quiz over APA, I got it wrong for like a couple of the attempts, but when there's an author with the same last name, can you clarify if there's 2 authors with the same last name, how you cite them?
So if there are authors with the same last name, if you have multiple references with the same author, it would go by either the publication year or the title. If you're talking about are you talking about an in-text reference?
Yes.
So in-text reference, same author, same thing. You might see a little bit of a like a lowercase a or lowercase b, just to distinguish which reference you're looking at. So sometimes people will find one author and they like numerous sources from the same author, right? So if that's the situation, then you're actually going to have to indicate it with like a little letter. I promise you, I'm not that strict in the exam. I can see Ryan's face like, oh my God, what are you doing? It is not that bad. It's more general. It's more of these things that I'm talking about, organization, maybe what's wrong with this sentence, you know, and a lot of times this is what you need to remember. It has to be formal, straightforward, so not a ton of jargon, unbiased, so no, something that's very common that still happens now is the male generic. That's considered biased language, right? Person first language. That means we don't say manic depressives, we say people who are bipolar. So we want to always remember that these are individuals separate from any condition that they might be experiencing. So that's another part that's really important in APA 7. Any other questions? So that would be basically APA 7 encompasses chapter 11, which is presenting your research. So then we have descriptive statistics, and you have that in both some calculations in part 2 and in part 1, some questions, you know, about maybe the way things are presented visually. So in terms of descriptive statistics, remember, the idea is to use a single number in terms of measures of central tendency to capture the gist of the data, which is really hard, right? What do you need to remember? Well, we have mean, median, and mode. There are appropriate times to use them. If you have extreme values, you do not want to use the mean, because the mean is very sensitive to outliers, to extreme scores. When you know there are going to be extreme values, you're better off using the median. That's why when we talk about housing prices, you don't hear them talking about the mean housing price, because we have $6 million, $7 million homes in the Bay Area. If you use the mean price of a house would be astronomical. So instead, you use the median, you order everything from least to greatest, order it and take the middle 2 scores, or the middle score, or the average of the middle 2 scores. The median is very resistant to outlier values. Mode is the only measure of central tendency that can be used with any scale of measurement. So remember, our wonderful friends, nominal, ordinal, interval, and ratio. The type of data you collect is going to determine what kind of analysis you can do. So mean is only, you can only use mean for quantitative data. You can only use mode, you can use mode for any kind, including qualitative data. Mode is the only one among the three measures of central tendency that can be used for qualitative data as well, because you're simply looking at frequency. What is the most common? So if you're saying favorite colors, you can come up with the mode, because then it's simply what is among, maybe 5 different choices that people selected the most. So you can do mode for anything. Measures of variability, we have range, standard deviation, and variance, right? Range is simply the difference between the highest and lowest score. Standard deviation is the average difference from the mean, and then variance is standard deviation squared. Clearly, with measures of variability, that is only for quantitative data. And then calculations, you need to know percentile and meaning, percentile rank, z-scores. You don't have to do correlations. You will have to do a t-test, and I think I put it here at the bottom. Normal distribution problems, percentile, sampling distribution, z-score, and t-test. Those are the calculations for part 2. Part 2 is only worth 25 points. There was a time when it was worth 50, and then I realized students did not do so great on this, so I did not want to hurt your grades that much, so I pared it down by, to only 25 points.
I have a question.
Other things to be, yes.
Later on, can you go over like a practice problem for that? Because
Yeah.
I'm still like lost on it.
Sure, I will do that. I will definitely do that. I just want to
Thank
make
you.
sure these topics are clear for people.
Mm-hmm.
Inferential statistics, the only inferential statistic you'll have to calculate is a t-test. But you do need to know how to interpret them. So that is another part. Remember, if we talk about a statistic, we're actually talking about a sample that we're looking at. When we talk about the population values, we're talking about parameters. So whenever you hear the word statistic, right away you should know, oh, we're getting these numbers from a sample. We're not getting it from the entire population. Outliers. So again, we'd think about the normal distribution. Outliers are more than 3 standard deviations away from the mean. That's how we identify it. We actually use z-score calculations to identify outliers. So that's another way to do it. And as I mentioned before, if you have a data set that is subject to outliers, you need to be very careful about which measure of central tendency you're going to use. Another important difference you should know, null hypothesis testing, right? That's the whole point to inferential statistics. So descriptive statistics, we are trying to summarize a data set. Inferential statistics, we're saying this data that we collected from our sample, we believe with X amount of confidence that we would also find these results in the greater population. That is the point to conducting studies. We don't just want to know what's happening with the sample. We want to set up our study with internal validity, with strong structural integrity, so that we can be confident in saying, these results we got from our sample group, we believe will also generalize to the greater public. So that's what inferential statistics is all about. You're taking results from a sample and putting it through analyses that will help you determine if those results will also generalize to other samples, other populations. That's what you're inferring. Any questions about that concept? Okay, so to be conservative, researchers are conservative. We don't want to assume that our interventions or anything are automatically going to work. So when we talk about null hypothesis testing, the null hypothesis is always there is zero effect of our intervention on our sample. So think null, 0. Conservatively, we always assume that the null hypothesis is true. What we want is our research hypothesis to be supported. We want to reject the null hypothesis. If we can, and we only reject the null hypothesis, if the probability of our results is the chances of those results occurring, purely by error is very, very low. That's why we have the p-values, the significance values. That's the point to that. So type 1 error. So if you think about it, actually, let me get the graph that will help. Hopefully this is all some review, right? I'm hoping, because if this is the first time you're hearing, I'm like, oh dear. Type 1, type 2 errors, right? You either are going to make an assumption about your sample that is true in the population, or you're going to make an assumption about your sample that is false in the population, right? Those are the two ways it can go. So here it is. And the way you can think about it is false positives or false negatives. So here, this is a fun one, but actually I think captures it extremely well. Type 1 and type 2 error. So a true positive is when you come up with a conclusion about your sample, and that conclusion is also true in the population. That's a true positive. If you come up with a conclusion in your sample, but it is not true in the population, that is a false positive, right? So it's like a doctor telling a man, you're pregnant. Clearly, there's a mistake in whatever data the doctor collected or whatever test he made, right? So that is a type 1 error, is a false positive. Is believing something is true when it really isn't. Another way you can do it is say, oh, this intervention doesn't work. It really doesn't work. And it doesn't work in our sample. It does not. And the truth is that it does not work in the population as well. So that is what we call a true negative. So you can have either a true positive where the intervention works in your sample and it will work in the population. And you can have a true negative where the intervention does not work in your sample and does not work in the population, right? But there are errors that can be made. So if you believe the intervention works, but it really doesn't, that's a false positive. If you believe the intervention does not work, but it really does, that's a false negative. And it depends on your study. So if the study is something really critical, like some kind of medication that people really need, you don't want to say that it's working when it's not working, right? So you need to be very careful about, and this is highly influenced by the alpha level that you have. So remember, our alpha level or confidence level by default is 0.05. Nothing else is said. We assume 0.05. That means, so if you want to interpret that, 100 minus 5 is 95. So you're 95%. You have confidence that 95% of the time, your findings will be consistent in the population. That's what you're saying with a 0.05 alpha level. Now, you can drop your alpha level. Sometimes I've seen 0.025, 0.01. So you could drop it down to, instead of a 5% alpha level, you could drop it down to a 2.5% alpha level or a 1% alpha level. If you drop it down to 1%, your chances of having a false negative increase a lot. So that's the kind of what you need to be aware of in terms of if you're going to mess with the alpha level. Generally speaking, for most things in psychology, a 95% confidence level is adequate, and we don't really want to mess with it. If you are studying something that you believe is really powerful, has a really huge effect, then you can make a very big statement by saying that your alpha level, you're going to drop it down to 1%, which means that you're confident that 99% of the time, your results will also be found in the population. You're only going to do that if you have a belief that whatever intervention you're doing is really that strong. So it's pretty rare to do that. Any questions about type 1, type 2 errors? Do you want me to go to calculations now? Are we good with those kind of concepts? Anything else?
Yeah,
Dr. Estrada, I had a specific question that was on the quiz where we were looking at the sample relationship, and it was looking at whether the stronger or weaker one is less likely to reject or retain the null hypothesis. I was wondering if you can go over that.
Let me, you said it was in the quiz. Let me look for it.
Yeah, I believe it was question 4, 3, 4.
Okay, let me find it. For chapter 13.
Correct.
And of course, my canvas is freezing. Okay, while I look for it, anything else that you need to go over?
what would be the null hypothesis?
Null hypothesis is that your intervention, there's no difference between the control group and the experimental group.
Okay.
It depends on what your hypothesis is. Like, let's say you want to know if a special type of therapy is going to work for anxiety. The null hypothesis is that the therapy will not be any different. Like, the results of anxiety will be the same for those who had the therapy and those who did not. That's the null hypothesis. And I'm glad you asked, because the research hypothesis can either be one-tailed or two-tailed, and you need to know this for the t-test. So when you have a research hypothesis, you could have it directional, meaning I believe that the people who have this cognitive behavioral therapy will have less anxiety than those who do not. It gives you a direction, right? If you just say that people will have a difference in levels of anxiety, you don't know if it's going to be higher or lower, we call that a two-tailed test. And it's important to read the hypothesis to know whether it's one-tailed or two-tailed. When we're talking about the t-test, it's going to make a difference in your critical value based on that. So yes, it is important to know the difference between one-tailed and two-tailed, and your research hypothesis will always be something about the intervention working. So, okay, let me go. Is it from a pretest? I'm trying to remember what it was. Eric.
It's specifically from the quiz.
Yeah, I'm looking at the quiz right now.
Question 4 was the blank the sample relationship and the blank the sample, the less likely the null hypothesis will be blank.
Oh,
and-
okay. Yes. So it's the stronger the sample relationship and the larger the sample, the less likely the null hypothesis will be true. So remember, null hypothesis true means that the intervention doesn't work.
The assumption for this question was that the reality is that the null hypothesis is.
Yeah.
Okay.
You got it right. That's right.
Gotcha.
Okay, anything else? Let me go back to the study guide really quick before we go on to calculations. So we talked about the p-value, alpha level, generalizability, cumulative components. This is a final exam. So research designs, you need to know your research designs. Pros and cons, and the other part that I know you all love is validity. So that has been kind of consistent throughout the class, the different types of validity, the big four, right? So that is construct, internal, external, statistical. Then you have the subdivisions of validity as well. So there are some questions on validity and different types of research designs. In terms of matching short answer, again, there are many different iterations of it. So you could have, in terms of matching, a type of statistic and which one are you going to be using? It could be a research design and threats to validity. In terms of short answer, there are APA format evaluations, like I said, what's wrong with this component. Also, I could give you a snapshot of an abstract, which I did in midterm 2, and ask you to identify different components of it. I also might ask you, okay, these are the results of the study. What does it mean? Is it generalizable? Is it significant? Is it not significant? What kind of study was it? What's the IV? What's the DV? Those kind of components too. And then the calculations, as I mentioned, the normal distribution, percentile, sampling distribution, Z-score, and t-test. Because you're taking the exam and it's due Wednesday night, the actual class is over Thursday. There will be an extra credit opportunity on Thursday, but it will require respondus, just letting you know. Okay, any other questions before we jump into
So
calculation?
you said it's due on Wednesday, the final?
Yes.
Okay.
So you have all day, you know what I mean? I'm giving you
Yeah.
time, plenty of time. The idea, I think, is that you want to take it early, take the first attempt early. Is really there's going to be up to 4 attempts, the two parts of the exam, which is why I'm giving you so much time. Take the first attempt early so that you can look back and say, oh, I really didn't understand this part. Study. You can message me. I will be monitoring the student Q&A in case you had questions, and then take it again afterwards. But remember that there are 2 parts. And I used to make people take all one part one day and the second part the other day, but people are different. Like some people want to get the calculations over with. Other people would rather start with the, multiple choice component. So I just left it completely open to you, for you to determine. Any other questions about that? Okay, so let's.
You said there are 2 attempts for the calculation part?
Yeah. Oh wait, no, sorry.
Oh,
Calculations only 1 because it's
I thought
no
there was only 1.
on the calculations. There's only 2. There's 2 attempts. I did not put a time limit on the
Okay,
calculation.
and then okay. I also had a question about what you said that would be included in the first part. We're going to be doing calculations of Z-score and t-tests on the first part?
No, second.
Okay, and for the critical values, will that be included on the math portion, or do we need to have those?
Critical values, it might be like 1 or 2 questions in the part 1. It's not something that you calculate. But critical value is something you'll calculate for the t-test. Confidence interval, that might be a question on the multiple choice. If that's what you're talking about.
Okay, yeah, but I'm just asking because for like the homework, the chapter homework, we had to look at the critical value table. That's what I'm asking about, if that will be
Yes,
provided.
so that will be, yes, it's going to be provided in the exam. So you need to know how to look at that table. And that's why I was saying it's important to know about the 1-tail, 2-tail component, right? So let's go to some calculations and I'll give you some samples. All right, so let's see. Oops, hold on a second. Let me fix this. Okay, can you see the slides? All right. So this is an example of something that would be like a frequency distribution probability, where I give you a scenario. So an alien empire is considering taking over planet Earth, but they will only do so if the portion of rebellious humans is less than 10%. They abducted a random sample of 400 humans, performed special psychological tests, and found that 12% of the sample are rebellious. So let's test the null hypothesis that the actual percentage of rebellious humans is 10% versus the alternative that the actual percentage is higher than that. So what you have on the right is a result of simulations, right? Each simulating a sample of 400 humans, assuming there are 10% rebellious humans. That's the null hypothesis, that there isn't any difference about this particular population you have. According to the simulations, what is the probability of getting a sample with 10% rebellious humans or less? So you have to know which part of the frequency table you're going to be looking at. If you look at the left-hand column, it says measured percentage of rebellious humans. So you have 6, 7, 8, 9, 10, 11, all the way up to 14%. But you're only interested in knowing what the probability is of getting a sample with 10% or less. So that's what you focus on. Oops. Why is it changing? There we go. So you'd look at the 10%, that's yellow over there, and then you look at the frequency. So I'm sorry, this is a mistake. That should be 327 over 1,000 plus 173 over 1,000 plus 93 over 1,000 plus 40 over 1,000 plus 7 over 1,000. That's slightly different than what I have here. So what you would do is take the frequency of each of the components that is 10% or less, and you would calculate what is the probability. So it becomes 0.64. Let's say it's 0.64. And you say, let's agree that if the observed outcome has a probability of less than 1%, right? So now we've changed the alpha level, we will reject the hypothesis. So what you have to look at is if it's greater or less than 0.01, which is what the alpha level would be. If it's greater than the alpha level, then you cannot reject the null hypothesis. You're going to retain it. So it's something along those lines. That is a probability question. So read the context, figure out what it is, that we're looking for, and then you're going to do the calculation, and you're simply going to compare it to the alpha level. So that's what the example probability question would be. Now, in terms of t-test, right? Is this the one that we have? Oh no, this is mean and standard deviation t-test. Again, you'll be given a problem. Sam Sleep Reacher hypothesizes that people who are allowed to sleep for only 4 hours will score significantly lower than people who are allowed to sleep for 8 hours on a cognitive skills test. He brings 16 participants into his lab, randomly assigns them to one of two groups. In one group, he has a participant sleep for 8 hours. I'd like to be in that one. And in the other group, he has them sleep for 4. The next morning, he administers the SCAT, Sam's cognitive ability test, to all the participants. Scores on the SCAT range from 1 to 9, with higher scores representing better performance. The standard error of difference, which I will always give you, is 1.18. Calculate the mean and standard deviation for each group, go through the steps for and conduct a t-test. So there aren't a lot of data points here, right? It's not a lot. I know that, and remember, you're not on a time limit for the calculations, so it's not too bad. And as you can see from this, I would give you the t-table so that you can calculate your t-value and then look at the table for the critical value. In terms of, this is if you want to do the standard deviation by hand, where you would take the mean, subtract every value, right, from the mean, and square the values, and then you would actually take the sum of it and find the square root of the variance, and you would end up with your standard deviation. You are allowed to use a calculator. There will also be one provided. A scientific calculator is also provided in the exam, so you can do this. So standard deviation, you would get the standard deviation for each group, right? And then you would use those values to find out what your t-value is. So you calculate the mean and standard deviation for each group. So one of them had a mean of 5, the other one is 4, standard deviation 2.14, standard deviation 2.56. In terms of a t-test, what do you need to know? You need to know the difference between the two means, and you need to know the standard of error, which I gave you. So the difference between the two means is just 1, right? Because mean of group 1 was 5 and the mean of group 2 is 4. divide that by the standard error, and you get 0.847. So that's your t-value. Now you need to compare your t-value to the critical value, and you find that through the table. So if I just said nothing else, you're going to assume the p-value is 0.05. And based on the context of the study, there was no direction, right? So you're going to look at it as a two-tailed test. If Sam said something, let me double check that. I think if Sam said that one group was higher than the other, then that would be a one-tailed test, but I believe it's just, oh wait, that is actually significantly lower. So that is direction. So you're going to look at a one-tailed test. So here on your degrees of freedom, you're going to look at the p-value, right? At the very top, it says significance level. You're going to look at 0.05. And then you're going to see which one is the p-value for a one-tailed test. And then you can look also at the degrees of freedom. It's the number of participants minus the number of groups. So that's 14. So you're going to look at the intersection of where the degrees of freedom is 14 and the p-value is 0.05 for a one-tailed test. It's kind of hard to see, but it's actually 2.145 plus or minus 2.145 is the critical value. If you were to draw that on a number line with a mean in the middle and the critical values negative 2.145 and positive 2.145, what you want to see is on that number line, does your t-value exceed the critical value? Well, 0.847 is not greater than 2.145, and it is not lower than negative 2.145. So because 0.847 is less than the critical value of 2.145, you fail to reject null. In other words, you need to interpret it. The means are not significantly different. Sam's hypothesis was not confirmed. He did not find a significant difference between those who slept for 4 hours versus those who slept for 8 hours. Questions?
I have a question.
Yes.
So when I was going through the study guide video that you posted previously, you gave examples where you said, I want you guys to interpret some findings from a test. And it
Right.
would show t parentheses, give it the number, and then it would say equals, and that would give us the t-value, and then it would give p equals a value. In terms of interpreting that example, the p-value, is that a synonymous then with really the level of significance when we go to the critical value tables? Okay, so that's not like p versus alpha in a
But
regular
so that is when you have the p-value and you're interpreting a result, that's telling you whether or not it has hit that significance level, right? So
okay, so it's a shortcut of sorts.
yes, it is. That's correct.
We got it. Okay.
All right, so let me go back to this. The other one to know, normal distribution problems. There are a number of different types of normal distribution problems, but it's all the same format, right? I'll give you the mean. So in this one, the weights of stray cats at a particular pound have a mean of 20 pounds with a standard deviation of 1.5 pounds. Assuming the weights follow a normal shape distribution, so I will give you all the information you need. What weight is 3 standard deviations below the mean? So right away, I would say, draw your little number line with the 20 in the middle and then calculate right off the bat 1, 2, and 3 standard deviations below and 1, 2, 3 standard deviations above the mean. And that way you can easily answer questions. 3 standard deviations below the mean. It would be 3 times 1.5, subtract that from 20, right? What weight is that? 2 standard deviations above the mean. Easy calculation. I might not make it that easy and I might mix it up, right? The middle 68% of cats weigh how much? In order to answer that question, you have to remember the 68, 95, 98 rule, right? 68% of the weights will fall within 1 standard deviation of the mean. That means you would, to find out the lower range, you would subtract 1 standard deviation from the mean. To find out the higher range, you would add 1 standard deviation to the mean. So in this case, you had 20 pounds. 1 standard deviation below 20 minus 1.5. The lower range is 18.5 pounds. You would add 1.5 to 20 for the higher range of 21.5. So the middle 68% of cats weigh 18.5 to 21.5 pounds. Right? What percentage of cats have weights between 18.5 and 23 pounds? So now you need to figure out how many standard deviations is 18.5 and how many standard deviations is 23. So all of these questions are designed to see, do you understand what that relationship is here for a normal distribution, right? That's what, so there's a number of different types of normal distribution problems. Questions about normal distribution?
Can you
Professor,
explain number 4? Oh, sorry.
go ahead. It's okay.
Number 4.
Can you explain number 4? Yeah, how you got the 0.5?
Oh yeah, okay, so if we look at this, right, here's the drawing I was telling you to do. You have the mean of 20, and then you have 3 standard deviations below and 3 standard deviations above. If you look, 24.5 is exactly 3 standard deviations from the mean. So in the question, what percentage of cats have over 24.5 pounds? The 68, 95, 99 rule will tell you 1%, right? But it's split into two. So it's either 0.5% is above more than 3 standard deviations above the weight, and 0.5% is below 3 standard deviations. So you're just kind of splitting up that extra 1%. Of course, it's really 99.7%, which is why the answer I put is 0.3, because you're splitting it. But what I want you to know is that 99% of the population is going to fall within 3 standard deviations of mean, which means that 1% are going to be at the extremes. So you split that 1% into 2, you have 0.5% will be above 24.5, and 0.5% will be below 15.5 pounds. Does that make sense? Hopefully. Question. Ask me a question if you don't understand.
Can you just go over it one more time, please?
Okay, so the 68, 95, 99 rule says that within 1 standard deviation, right, 68% of the data is going to fall there. So because it's within 1 standard deviation, that means half of that 68 is going to be below the mean. Half of the 68 is going to be above the mean. You always have to keep that in mind, right? So that's 68%. If we go out to 99%, which is 3 standard deviations, so if we say 99% of the data will fall within 3 standard deviations, half of that is going to be below 20 pounds. The other half is going to be above 20 pounds. Do you follow me that much?
Yes.
Okay. So that's 99% of the data. All that's left is 1%, right? But we're always taking the middle values. So that means you have to divide the 1% into 2. So 1 divided by 2, 0.5% of the population will have a weight over 24.5%, and 0.5% of the population will have a weight below 15.5%, and then you've captured the entire 100% of the data. Does that help?
A little, yeah.
Okay. Yeah, I think the thing to keep in mind is that when we do that rule, right, we're always thinking the mean is in the middle. When the mean is in the middle, that means that half of it will be below and half of it will be above. But in that question, I'm only asking above. I'm only asking for half of it. And that's why I say approximately 0.5%. What percentage of cats have weights over 24.5%? I mean, over 24.5 pounds. 24.5 pounds is 3 standard deviations above the mean. And so to figure out what percentage would have over that, it's going to be 0.5%. Because you have 99% are going to be less than 24.5 pounds. So you just kind of remember always, we're not only talking about one side when we talk about the 68, 95, 99 rule, we're talking about both sides of the mean, below and above. Okay, we'll try
So
another.
if,
Go ahead.
oh, sorry. So if you were to ask about what's
No worries.
over 23, which would have been the 95 rule, that would be, your answer would be 2.5. I'm just trying
I'm
to
not,
see if I applied to the other.
I'm not sure what you're asking.
Like if that example,
Okay.
because that example was for the above a certain number, which was 3 standard deviations. But if it was the number where it was 2 standard deviations, which would be the 95%, then if we were
Right.
trying to calculate that, because it's a 5% difference, it would be 2.5, because of 2.5 would be on that side, 2.5 would be on
Would
the other
be
side.
greater than 2.5 because let me show you the thing. Uh-oh, hold on a second. Oh, okay, I just lost it. Let me go back to it. Okay, so here we have it. So 1 standard deviation above would be 21.5. So if you said, if I asked you what percentage is greater than 23, is that what you're asking? So,
Yeah, that would,
okay, go ahead. What are you thinking?
like, because it's 2 standard deviations, that would be a 95. So then it would be a 2.5%?
Yes, that's right. Yeah.
Okay.
You're,
Okay, that
you're,
makes
you're
sense.
doing the remaining part, but you're splitting it into 2. That's right.
Okay.
So the other kind of questions that I would be asking are z-scores, which are really important to know as well. And the reason that z-scores are so important is because it puts everything into standard deviations. It takes away units, which is helpful when we're comparing measures that have different units, right? So for example, let's say, and it's always relative to another group. So Logan took a midterm with 75 questions on it. His score was 65. The final exam is 100 questions and Logan's score was 80. Was Logan's score on the final exam relative to his classmates better than his relative score on the midterm? So the key here is the relative to his classmates. Because if you just wanted to know if Logan's score was better on the midterm or the final, you just take the percentage, right? But the percentage by itself doesn't tell you how he did compared to the class. So it's using the standard deviation that helps you understand that relative component to the question. So I give you the information. The mean of the midterms, this is the mean score for the class, was 52.5. Standard deviation is 5.5. The mean of the final is 75.5 with a standard deviation of 6.4. So what you need to do to answer this question is get the z-score for the midterm and the z-score for the final, and then figure out which one is better. Okay, so z-score for the midterm. You take the score of interest, which is 65, Logan's score of 65, minus the mean score of the class, and you divide it by standard deviations. By dividing it by the standard deviation, right, you're eliminating that unit part. It doesn't matter that it was out of 75. So you get 12.5 divided by 5.5, 2.27. So Logan's score on the midterm exam was 2.27 standard deviations above the mean. That's what it's saying there. Now let's look at the final. Go through the calculation. Logan's score minus the class mean divided by standard deviation, and it's 0.70. So for the midterm, Logan's score was 2.27 standard deviations above. And for the final, it was 0.7 standard deviations above. So what's the answer? Was it Logan's score better on the midterm or the final relative to his classmates? Anybody?
On the midterm.
Yeah, exactly. Is it clear how to do this one?
How do you figure out the X and the M for the equation?
The X is the score of the person. That's your score of interest. So in terms of this, Logan's score is the X, and the M is the mean of everybody else, the class mean.
Okay, thank you.
Any other questions? Okay, let's go back again. Let's try this normal distribution. Raccoons have an average weight of 13 pounds with a standard deviation of 2.5 pounds. Assume the weights follow a normal shape distribution. What is 2 standard deviations below the mean? So how would you calculate that? Well, 2 times 2.5, right? 2 standard deviations below the mean. So that's 5 and subtract it from 13. That's 2 standard deviations below. What weight is 1 standard deviation above the mean? Well, that's easy. You just add 2.5, which is, 1 standard deviation, to the mean of 13 pounds. Middle 95% of raccoons weigh how much? So again, thinking about the 68, 95, 99 rule, how many standard deviations do we have to go out to get the range for 95?
2.
Maybe
2
go
above and 2 below.
correct. That's right.
Mhm.
And then the last one is, what percentage of raccoons have weights between 10.5 and 18 pounds? So if you did what I suggested and you draw it out, you should be able to answer all these questions fairly easily, right? 10.5, if you think about it, 13. So just, okay, 13 minus 2.5, you have that, right? Is 1 standard deviation below. And then 18 is 2 standard deviations above the mean. So now you figure it out through the 68, 95, 99 rule. And you'd say 81.5% of raccoons have weights between 10.5 and 18. So many iterations of these normal distribution problems can be created. It's so easy. So here's kind of that drawing of raccoon weights where the mean is 13, standard deviation is 2.5. And I, kind of mapped it out, 34%, 34%. If you add, this is how the normal distribution ends up if you do the 68, 95, 99 rule. Questions?
How did you get 34?
Or, I'm sorry. So 34%,
Standard deviation.
right? 34% is within 1 standard deviation. So in this question, this one's a little harder because it's not as easy as what is 2 standard deviations below. You have to have an understanding of the 68, 95, 99 rule. So 10.5 is 1 standard deviation below the 18, right? So let's see, below, sorry. 34, 10.5 is right here. So that's 34% over there. And then you want to say 18 pounds is 2 standard deviations above. Okay, so that first 34 is from the 1 standard deviation below. The next 34 is 1 standard deviation above, and then 13.5 is the next standard deviation above. So if you look at it broken down, 34 is 1 standard deviation below, 34 is the 1 standard deviation above, and the 13.5 is how much is captured when you're moving over from 68, 95, 98 rule. So then you would just add that component And that's how you end up with the 81.5%. Yeah. So you need to know the breakdown of the 68, 95, 99 rule. Questions? Anything else? Ready? I mean, if there are no questions, I'm going to make the assumption that you know it all. Is that an accurate assumption? I think not, but I want you guys to ask me questions.
I just want just to go over more practice problems.
I only have a limited number of practice problems, so I don't know what to say in terms of that. Maybe I should create more, but we don't have time at this point. That's why you're supposed to do the homework. The homework asks for the normal distribution components. I guess now it's more about conceptually, where are you having trouble?
Oh no, I'm just rewatch the review. Like I'll go over this review and then
Okay.
yeah.
Try to answer the questions on your own and see if you come up with the same. You know what I mean? That's really,
Yeah.
and then understanding that, because obviously on the exam, they're going to be different numbers. So the concept, you need to really make sure you're comfortable with the concept of the whole 68, 95, 99 one for the distributions. The other part I do want to address is those interpretations of the hypothesis testing. Let me find that. Because I'm quite sure you can have some questions on that. Let me go to that. Okay, so as I mentioned, I'm not making you do the actual analysis, but I think you should be able to understand what what it means, right? Like interpret the results. So let me go to this one. Oops. Okay, significance level, kind of talked about that, right? That the default is 0.05. And the way to interpret that is like 5% chance that it's just happened by accident. So you want to be sure, you want to be so sure about your study that it is unlikely that you got the results through random error. If that's the situation, you would reject the null hypothesis, which is what we want. Some things to make note. These are mostly quantitative studies. So the larger your sample or the more data points you have, the more likely you can find a value that's close to the population value. That's what you really want, right? As your sample size increases, your confidence that the outcome differs from the null hypothesis increases as well. So one thing in this age of data mining is that there could be such a thing as so many data points that you could find something that's statistically significant, but not meaningfully significant. And that's the difference between statistical significance and practical significance. So let me give you an example. Let's say you did a study and you wanted to see the effect of caffeine on cognitive performance. Okay. And so you did a study where somebody drank 8 cups of coffee and it improved their cognitive performance by 0.5%. But because you had thousands and thousands of people do this study, that became a statistically significant result. But does it have practical significance? Would you advise somebody drink 8 cups of coffee to have a 0.5 difference in cognitive performance? Hopefully not, right? So it is always important for you to distinguish between the two, even if statistical significance is the result of an analysis. right? The larger your sample size, the more likely you are to find a statistical significance. But you have to interpret the results. If that significance is for something that is so small that is not practical, then that's not really useful to anyone. And so it's not enough for a result to be statistically significant. You should also make sure that there's practical significance to whatever the finding is. That's my point there. Any questions about this one? Okay. So Cohen's d gives you an understanding of the effect size of any kind of intervention that you might have. If you have a strong effect, then you don't need that many people to find that difference between the two groups. Nowadays, most of the things will have a weak effect size, and so you'll need a much larger sample size to find any kind of significant difference, right? So that's really the main point with Cohen's d. All right, so let's go to the type. So remember, chi-squared is more about percentages. If you're comparing group percentages and you want to know, is one percentage greater than the other? So chi-squared results, you can use it for nominal and ordinal variables. It's the only inferential statistic can do that for. So here's the results breakdown. What you're going to see is a big X with a squared, and that tells you it's a chi-squared analysis, right? The 1 is the degrees of freedom. So it's actually R minus 1 times C minus 1, which is how many are in the rows minus 1 times how many are in the columns. But we're not looking at the breakdown of the table. Generally, it's number of groups minus 1. But for a more specific calculation, it is R minus 1 times C minus 1. N equals 54 tells you how many participants there were overall, and then the p-value indicates the alpha level used by the researcher. If it says something like this, it is less than 0.01, then the result was significant. So here are some example chi-squared results. You will not get a result that says a chi-square test of independence was performed. You're more likely to get one of the two, something like the middle ones. The proportion of subjects who reported being depressed did not differ by marriage. Chi-squared 1, n equals 104 equals 1.7. That's your chi-squared value. P is greater than 0.05. So the x squared, you see the green one, that means it was a chi-squared. 1, there were two groups, right? It's generally two groups, 2 minus 1, and that's 1. The n tells you how many participants there were. And then the p-value tells you whether it was statistically significant or not. When you have p equals greater than 0.05, there was no significant differences, which is why it said the proportion of subjects who reported being depressed did not differ by marriage. So your interpretation of this was that marriage did not make a difference in terms of the levels of depression for the people who were assessed. Questions? I think this is pretty straightforward, right? So if you see the funky looking X, it's a chi-squared value. Okay, so I kind of broke this down, and this is posted in our module. So group means t-tests, right? So there are 3 types of t-tests: one sample t-test, dependent sample t-test, and independent sample t-test. One sample t-test, you're comparing it to the population. Dependent sample t-test is called dependent samples because you're actually doing repeated measures. It's the same group. And then independent sample t-test would be for a between groups study that you're looking at. We're comparing 2 completely different groups. That's why it's called independent sample t-test. So in the one sample t-test results, you're going to see something that says about the population norm. So again, you're going to see the t, which tells you is a t-test, and you're going to see a value in between the 48, right, equals 2.3, p equals 0.026. So in terms of degrees of freedom, it's how many participants minus the number of groups being examined. So for a one sample t-test, you're going to see some kind of verbiage about the population as a whole. Once you see that kind, then you're like, okay, this is a one sample t-test. I already know that. You can look at the p-value. If the p-value is greater than 0.05 and nothing else is stated, then it's not significant. But in this case, it is significant. 0.026 is lower than 0.05, so it is statistically significant. Independent t-test, you're going to see mention of two completely different groups. The 25 participants who received drug intervention, and APA says that you need to indicate the mean and standard deviation of each group. Those who received the drug intervention compared to the 28% participants in the control group demonstrated significantly better peak flow scores. So I would remove the significantly better part, but I would just say demonstrated the following peak flow scores. Again, you see it's a t-test, right? You're going to have 51 because you had a total of 54 minus 2, sorry, 53 minus 2. And then you see p equals 0.04. That's less than the 0.05 threshold, so that's why it is statistically significant. So you need to look at the result. From the result, the verbiage, determine, is there only one sample? Is it being compared to the population? If so, it's a one sample t-test. Are they two different groups? If it's two different groups, then it's independent t-test. And then if it's a dependent t-test, you would know because it'd be like a pre-test, post-test situation. The results from the pre-test and post-test memory task indicate that the presence of caffeine in the bloodstream resulted in an improvement in memory recall. So read the context of the results to figure out what kind of t-test it was that was conducted. Any question here?
So the number then in the parentheses after the T is actually different degrees of freedom.
Right.
When there's multiple groups and you need to add the number of groups that are being compared.
Correct. For the total number of participants. Yep, that's right. Okay, so this is another kind of breakdown of what kind of test it was, the degrees of freedom, which is number of participants minus number of groups, and then your alpha level. And then if you're having two or more groups, you could do an ANOVA, right? Analysis of variance, also known as the F test. So chi-squared looks like an X, T test is a T, correlations in R, ANOVA is an F. That's why it's called an F test. And yes, it's really long results that you would have. So you need to know which part you're looking at. Well, in an APA style results, it'll tell you it was a one-way between subjects ANOVA. This is the conditions. So effect of sugar on memory tells you that the dependent variable is memory and the independent variable is sugar. What are the conditions? Sugar, a little sugar, no sugar conditions. So there are 3 levels in this. And then it tells you that they did get a significant value, that there was a difference. So one thing to know about ANOVA, the results don't tell you which group had significant differences. It just tells you there was a significant difference between at least 2 of the groups. And then you have to do post hoc comparisons to find out what they were. So that's why it says post hoc comparisons using the Tukey HSD test indicated that the mean score for the sugar condition, so that's mean of 4.2 with standard deviation 1.3, was significantly different than the no sugar condition. So that's where the difference was. So whether people had sugar and no sugar, that's where the big difference was. The little sugar condition did not significantly differ from the sugar and no sugar conditions. Need to know the interpretation. These results suggest that high levels of sugar really do have an effect on memory for words. A result suggested that when humans consume high levels of sugar, they remember more words. However, it should be noted that sugar level must be high in order to see an effect. Medium sugar levels do not appear to significantly increase word memory. So hopefully you see that I care about the interpretation and that you know how to interpret these things. So there could be questions on that component, like what does it mean, right? And it could be multiple choice, or it could be that you just tell me, what do you think it means? But it's important not to just stop at calculations, that you actually have to demonstrate that you understand what the significance is. Correlations, you're looking at, if you see the R, you're not conducting it, you're just interpreting it. R in parentheses is degrees of freedom, equals your R statistic, and then your p-value. So if you have R 112, that's your degrees of freedom. And then P equals 0.012, right? So the correlation here is 0.6, which is pretty good. That's a fairly strong correlation. You could have a weak correlation like 0.34 and still have it be statistically significant. So make sure you understand the difference between correlation strength and statistical significance. They're actually two completely different things. You could have a very strong correlation that's not statistically significant for some reason, right? Or you could have something that has a really low p-value, p.0001, and it being a weak correlation. So make sure you know that there is a difference between the two. Okay. A confidence interval, the idea with confidence intervals is that if you have a really wide confidence interval, it's not actually that helpful, right? You could be really confident. It's like saying, okay, here's the weather for tomorrow. It's going to be anywhere from 58 degrees to 88 degrees. Well, that's great. You can be super confident that that's the situation, but is it actually helpful when it's such a wide range, right? Probably not. So you want confidence intervals to be narrow and precise. That's the idea there. If you have a large standard of error, then it's a large interval and it's not really strong results. That's really what you're going to take from that one. Okay, just to recap, research strategies: descriptive, correlational, experimental, quasi-experimental, non-experimental. And there are many subtypes underneath, but those are the main research strategies. When you're doing descriptive research, you're really looking at what's going on, what's the current state of the variables. So all you're really doing in descriptive research is finding out what's involved in this phenomenon. You're not looking for relationships between variables. Oftentimes, descriptive research is when it's something fairly new or unique, and you're just trying to figure out what variables are involved. Okay, so that's descriptive. Snapshot of specific variables in the population. Correlational research can only happen after you've done descriptive research, because once you know what variables are involved, now you want to know, how are these variables interrelating with each other? Is there a predictable systemic way that they are moving in conjunction? So with correlational research, you want to know, how are these individual variables related to each other? One group, at least 2 variables measured for each individual. What you're looking at to see is, are there changes that are consistent and predictable? So you're looking at linear correlations. It could be a curvilinear relationship, positive, negative. Remember that positive or negative does not indicate the strength of the correlation. It just tells you whether they're moving in the same direction, which means positive, or in opposite directions, which is negative. Any questions about correlations? All right, experimental, quasi-experimental, non-experimental. We're looking at 2 or more groups with score of measurement on the same variable, right? The differences, right? Experimental have to meet those 3 criteria. There has to be covariation of the variables. So you already have to know that these variables are moving together. Temporal precedence has to be established. That is only through the manipulation of the independent variable, that after you manipulated it, then you saw a change in the dependent variable. And the third part to an experiment is random assignment. right? You're eliminating alternative explanations for what you're finding. If any of those components are missing, you do not have an experiment. Quasi-experiments attempt to control extraneous variables as well. Oftentimes, and some people say that quasi-experiments, you don't manipulate the independent variable. You do manipulate the independent variable in a quasi-experiment. What's missing is random assignment. So in quasi-experiments, we do that in situations where it would not be ethical to like make people have cancer, things like that, right? So you often see a lot of medical interventions would actually be in a quasi-experimental mode. Non-experimental means there's no manipulation of the independent variable, no random assignment, right? We're not trying to control anything. We're just trying to see things that exist as they are. So in terms of validity, experimental designs have the highest internal validity because of all the control you're exerting. Non-experimental methods have the lowest internal validity, but the highest external validity. Remember that there's always that trade-off. The more control you have over a situation, the less natural it is, right? So that reduces the generalizability. If you have to choose between the two, go for strong internal validity, because the way to expand your external validity is to conduct the same study with other groups. That's how you'd expand external validity. If you have to choose between the two, always go for stronger internal validity. Any questions about this one? All right. So if you got to pick the right statistic, you need to know the type of data collected, right? Your scales of measurement, number of groups, number of variables, is all stemming from the research question. So in your research proposals, that's why, I asked, what's your research question? If your research question says something about the effect of blank on blank, I'm going to look for an experiment. So I have the rubric, and you should all be aware of that. I will be going through things. I'm not going to message you about your research paper, tomorrow night, because I'm expecting that you're doing the exam. But I will send some messages, maybe Wednesday night, pretty late or something, just so you have time to make any adjustments needed before the class is over. Any questions about this right statistic? Okay, so these, you are welcome. I'm not putting these on the exam. But when you go to grad school, I strongly recommend that you keep these diagrams, because it took me a long time to put them together. And what this is it tells you the kind of descriptive statistic and inferential statistic you can use based on your research, what kind of data you're collecting, how many groups you have. It will be very helpful to you when you're actually conducting your own research. And there was a class that had this on, but I learned. So be grateful for your previous classes. And then, okay, we already talked about the different types of t-tests, I think. Yeah, and this is okay, in terms of the there is a t-test on your part 2. It is worth 10 points. So you want to make sure you know how to do this well, right? What are things that I'm going to be looking for? I will probably ask you what is the IV and the DV. I will ask you for your t-value, which means you need to calculate that with the standard error of difference. And you want to make sure you kind of type out your work, because if you make a mistake, I can still give you credit if you give me some work. If you don't show any kind of work at all, then it's just going to be wrong, and that's going to be awful for you. So critical value of t, tell me what you think the degrees of freedom are. That's important, because if your degrees of freedom are wrong, then what you look up is going to be wrong. But if I see that it was okay, you made one mistake here, but everything else is correct, I can still give you credit. So you want to make sure I do that. So degrees of freedom, number, n minus the number of groups, right? So how many participants were there? How many groups were there? Subtract it and you get the degrees of freedom. If there is a direction specified, it's a one-tailed test. If not, it's a two-tailed test. Look at the critical values. Okay, nothing was said. It said that, okay, 0.05 because the question didn't say anything otherwise, right? And you look at the degrees of freedom 18, look at the intersection, there's your critical value of 2.101. I will ask what is the critical value. So I will ask you for probably IV, DV, that's maybe one or 2 points. I'll ask you for your T value, right? You have to do that calculation. I will ask you for your critical value. And then you need to come up with your conclusion. So the conclusion is not just the calculation, you have to interpret it. So in this one, the hypnosis group had significantly greater reading retention than the control group. I need to know you understand the interpretation of the results. It's not enough to just plug stuff in. Any questions about T value? So you can see it's worth 10 points, but it's not all on one answer. It's like broken down so that you can earn partial credit on things. My recommendation, even if you blank out during the exam, try to answer any of the questions, please. If you leave it blank, I cannot give you anything. Okay, and then, oh, so here's an example where I might do it for an ANOVA, okay. Methods used are reality therapy, behavior therapy, psychoanalysis, gestalt therapy, and control group. 20 patients are randomly assigned to each group. At the conclusion of the study, changes in self-concept are found for each patient. Purpose of the study was to determine if one method was more effective than the other. They found F 425 equal 18.92, P is less than 0.001. So what does that mean? Remember in ANOVA, all it tests is if there's a difference, if there's a significant difference. You don't know which one had the difference. So in terms of this, what you can say is that among the 5 different therapy types, there was a significant difference in self-concept, right? P equals less than 0.001. So one of them, at least one of them, had a big difference in the patients. So I could ask you questions like, what is the null hypothesis? What's the alternative hypothesis? Make a decision regarding the null hypothesis and state your conclusion. So you're not conducting the analysis, but you are interpreting it. Any questions? Remember, no questions means y'all got it. So when I say give me an interpretation, right, there's no significant difference among the section scores, fail to reject the null hypothesis. So if you read this example, 3 professors were each teaching one section of a course. They gave the same final exam. They want to know if there are any differences between their section scores. So when you went and got the results, there's no significant difference, so you fail to reject the null hypothesis. Remember, the null hypothesis is always there is no difference among the groups. If that's what you find, then you fail to reject it. If you find there is a difference among the groups, then you reject the null hypothesis. And that's it. Poor Sheila, she's falling asleep. Questions? Bottom line, it's just an exam, right? Do your best, breathe, don't forget to breathe. Part 2 is only one attempt, but you don't have a time limit, so you don't get stressed out. I did that on purpose so that you'd be like, okay, right? Because if I put a time limit, I know that what that can do to people cognitively, right? So part 2, get comfortable with try the practice final. That kind of gives you an example of what it'll be under those conditions. And then think about the way the calculations are. Make sure you answer everything to the best of your ability. Don't leave any blank, because once it's blank, I can't do anything with it. I really do try to give you credit where I can give you credit. Okay, part 1, APA is a big thing, so make sure you get comfortable with that. I strongly suggest you look at the sample annotated paper, because that will probably prepare you fairly well for the APA parts and what to look for it. I really like I circled everything and highlighted everything I'd be looking for. And then think about the different research designs, validity, fun, reliability, right? Some of the things that I've noticed is some people are conflating the two. They're not the same thing. Reliability is not the same as validity. Any questions before we go?
That last example you
Don't
gave,
forget to breathe. Mhm.
that type of question is on part 1, where we have to interpret the results.
Yes, that is correct.
Okay.
So remember, you can have 2 different cheat sheets, both sides, right? So calculations, I would maybe put a sample thing and like just highlight what the different parts are to look for. That's what I would recommend for the calculation part. I already tell you what kind of calculations you're doing. I would definitely have the 68, 95, 99 on your cheat sheet broken down so that you can interpret things. Any questions? Any other questions?
Can you just go over that rule one more time? The 68 and 95 rule.
Yes, hold on. Let me pull it up. I think it's helpful to have it to look at. And I think the part that's most helpful is actually when I broke it down. I have too many things up. Okay, while I'm looking for that, anything else? Oh, here. Yeah.
Do you also need us to send you the cheat sheet as well, or it's okay?
It'll be you would have to upload it, definitely.
Okay.
So here, there are 2 ways to look at it, right? So there is this way, which is more accurate, right? 68.3, 95.5, 99.7. But we round it to 68, 95, 99. So 68 means that 68% of the data will fall within 1 standard deviation of the mean. 95 means that 95% of the data will fall within 2 standard deviations of the mean. And then 99 says that 99% of the data will fall within 3 standard deviations of the mean. It's actually 99.7, but anyway. The other part, so I would recommend you have this drawn in your cheat sheet, and the other part to help you is this here where I broke it down. So you have 34% is 1 standard deviation below the mean. Additional 13.5% would be 2 standard deviations below the mean, and then an additional 1.5% would be 3 standard deviations below the mean.
So it'd be going downwards from the top?
Downwards, and then you have the top part, because it's not always going to be, if I say the middle 68, I'm being nice, right? That's the easiest way to do it. I can mix it up and say, what percentage is, 2 standard deviations above the mean? If I said that, then you would have to add 34% to 13.5%. So you would get 48.5% is 2 standard deviations above the mean.
What would be like a more complicated one?
Well, we're kind of that one that I said where it was like 1 standard deviation below and 2 standard deviations above, where I'm kind of, you'd have to add it up. That would be as complicated.
Okay.
Yeah,
Okay. Thank you.
sure. Any other questions?
I have a quick question. I'm not sure who asked about the cheat sheet upload, but there's no like assignment for us to upload it on the.
I will upload it. I'll open it up tonight.
Oh, okay.
Any other questions?
Everything has to be written. We can't like print out that graph you have.
Correct, it's handwritten.
Okay, thank you.
There's a reason for that, by the way. You actually remember things more when you're handwriting.
Yeah.
You're using synapses, so that's why I insist on it being
That definitely helps for me.
yeah.
Yeah. I have to rewrite notes all over, like over and over again.
It helps. It actually really does help with retention.
Yeah.
Any other questions?
This will be uploaded right after.
When it takes about an hour or so for the recording to come back to me, and then I'll post it. I'll post it with all of the resources like I normally do.
Okay, thank you.
I got a question. For chapter 12 and the other study guide video, you referred to those slides a fair amount, but I noticed I didn't see chapter 12 slide deck on Canvas. Was there a reason for that?
I just forgot I posted it.
Oh, great, cool, thank you.
I thought I wrote back to you and let you know. It's posted. It is posted. So I believe I have everything. If there's anything you notice that is missing, message me and I will take care of it.
Thank you.
Any? Okay.
Are you also going to update like the other assignments, like past assignments? Like I haven't had my midterm not graded yet, and
I'm working on that totally.
okay. Yeah.
I'm sorry, I apologize for that. Yes, I'm going through it. I'm trying. I think what I'm gonna do is I'm gonna hide it until after the final and then release everything because I think it'll just add more stress to people if they see scores coming in. I don't know. You're all here. You tell me, would you rather see the scores coming in or
I
wait?
kind of want to see some scores coming in so I know like where I'm standing at right now, just so that, because if it's,
Okay.
yeah. Thank you.
Sure. Anything else? Already then. Thank you all for your patience and for like going through this. I know it's not easy. I understand that. And suggestions for improvement, totally open to it because I do want to be a better teacher. And I know one of them is like the grading has been rough, but other than that, providing resources and other things that you think would be helpful to future students, I'm happy to hear from you.
Nothing more than the opening question of, is there a way to just do the class online over 16 weeks as opposed to, was it 8 or 10? Yeah, the base.
Yeah.
But everything else, totally fine.
Okay, thank you. I will, yeah, I don't want to do this in 8 weeks again. I mean, the time we do it in the summer, but again, that's meant more for people who need it and who've been through it and just didn't do so great in the regular semester and are ready to do it quickly the second time around. All right, thank you all so much.
Thank
Good
you.
luck. Okay.
Thank
Take care.
you.
Yeah.